So those three create congruent shapes: reflection, rotation, and translation. Reflection is just where something's flipped over an axis. Rotation is where something spins. And translation is where something just stays in the same orientation but just slides somewhere. All those create congruent shapes. You're not changing the size. You're just moving it around. The other transformation, which was a dilation, that does change the shape. A dilation was either stretching it, making it big, or shrinking it and making it smaller. This makes or creates similar shapes. So the pre-image and the image will be similar, meaning the angles will be congruent and the sides will be proportional if it's a polygon. The reason I want to mention that is because yesterday we were talking about, to show that something is similar, we have to show that all three corresponding angles are congruent and all three corresponding sides are proportional. Well, if you can show that there's some kind of dilation going on, then you can automatically say that the shapes are similar. So that's what I'm going to write down next. If you can show that a shape underwent a dilation, then you can prove the two shapes so pre-image, which is the beginning, and image, which is the end. Those are the two shapes. Pre-image and image are similar. So you can prove that. If you can write down a dilation, some rule for a dilation, then you already know that the two shapes are similar. And I'm saying, recall, if you had some rule that takes x and y coordinates and you multiply them by 3, this would be a dilation with a scale factor of 3, or by a factor of 3. So with this rule, this would be a scale factor of 3. And this gets bigger by 3. It's not you're adding 3 units to each side, you're multiplying by 3. So if you have a side that's 5 units long and you use this dilation, that side would then become 15 units long because you're multiplying by 3. The scale factor is actually also the similarity ratio. Also is the similarity ratio. The scale factor and the similarity ratio would be the same thing. If you're getting smaller, it would be 1/3. So scale factor of 3, that means whatever the shape is getting bigger. And if you wanted to go smaller, it would be 1/3. You'd multiply by 1/3 or divide by 3. But I'm just going to say that and not write it down. Yesterday, we needed to show that all the angles were congruent and all the sides were proportional. Then we could say that the two shapes were similar. Today, if you can show there's a dilation happening, then you don't need to do all those other things. You can just already say, yep, they're similar. Also, this is angle-angle similarity theorem. if two angles from one triangle are congruent to two angles from another, then they're automatically similar. If two angles from one triangle are congruent to two angles of another triangle, then those triangles are congruent. Sorry, not congruent, are similar. So now we have three ways, basically. You can show that all the angles are congruent and all the sides are proportional. Then you can state that the two shapes are similar. Or you can show that there's a dilation happening by writing down some rule like this, or by verifying some rule like this. Or if you know that two angles from one triangle, if there's triangles, if it's like a polygon that has more than three angles, so like any, like a four-sided shape that's not a rectangle or square, or five-sided, six-sided, those you can't use angle-angle similarity. Angle-angle similarity is only for triangles. But if you can show that two angles are congruent to two other angles, then we know that the third angle is congruent by the third angles theorem. And this tells us that the triangles are similar.